So this problem says a flywheel of mass, moment of inertia 100 kg meter squared, rotating at 500 revolutions per minute, is brought to rest by friction in 2 minutes. What is the frictional torque on the flywheel? Okay, so friction force is a non-conservative force. A non-conservative force is equal to final energy minus initial energy. Well, here we don't have any potential energy, so in this case this is equal to potential energy, kinetic energy, potential energy, kinetic energy, initial. Oops. The potential, there's no potential energy, so it's final kinetic energy minus initial kinetic energy. Final kinetic energy is 0 since you brought it to rest, and frictional torque is the work done by friction is the frictional torque times the angle through which the flywheel rotated. So we'll have to calculate the angle, okay, but alright, so the torque will be initial kinetic energy divided by the angle through which the flywheel rotated when it's in coming to a stop. Okay, so initial angular velocity is 500 revolutions per minute, and that's equal to 500 revolution is 2 pi, each revolution is 2 pi radians, and 1 minute is 60 seconds. So this is equal to 52.4 radians per second. And so okay, let's find alpha. Do we need alpha? Yeah, we'll need alpha. No, we won't need, yeah, we will need alpha. Okay, so omega final is equal to omega naught plus alpha t. Alpha is omega minus omega naught over t. And the wheel was brought to rest in 2 minutes, which is 120 seconds. So this is 0, final velocity is 0, initial velocity is 52.4 radians per second, and the wheel was stopped in 120 seconds. So alpha is equal to, divided by negative 0.44 radians per second squared. Alright, now that we have alpha, let's calculate theta. So what we're calculating is theta minus theta naught equal to omega naught t plus 1/2 alpha t squared. Okay, so this tells you through what angle did the flywheel rotate before it came to stop. Okay, omega naught, the initial angular velocity is 52.4 radians per second. And the stopping time was 120 seconds, 2 minutes, plus 1/2 alpha is negative 0.44 radians per second square times 120 seconds square. Okay, 3120 radians. So that's the angle through which the flywheel rotated before it came to rest. Okay, so now the torque, the frictional torque is initial kinetic energy divided by theta, and that's the magnitude of the torque, and so that's 1/2 I omega naught square divided by delta theta equal to 1/2 I is 100 kg meter square. Omega naught is 52.4 radians per second. Square, and delta theta is 3120 radians. Okay, and so this is a torque, so it'll work out in Newton meters, and this is equal to 50 into 3120, 44 Newton meter. So that's the magnitude of the torque. Okay, that finishes this problem.